Hi guys, welcome to our video on the Esterification lab. Here we're going to help you prep your lab notebook and get you ready for the lab itself. So you'll need your lab notebook, the unit 2, that should be unit 2, sections 1 and 2 packet. Sorry about that. Let's see. So that's the unit 2 packet, sections 1 and 2, and your textbook. In your textbook, we're going to be using pages 173 to 175. So for your introduction, you need a paragraph. It should include each of these following points. What is esterification? Describe what esters are. What compounds are needed for a typical esterification or ester synthesis? How does the reaction occur? And use chemical equations and symbols to clarify any thoughts. Use APA citation. So I suggest going to OWL Purdue. They'll show you how to cite any online sources. And use reliable resources. So anything that's a .edu will be good. Your hypothesis. You're going to predict what the compound in this lab will smell like. We have 3 different compounds that we're making. So you'll need 3 different hypotheses. And don't forget your hypotheses are in the if, then, because statement. And to help you out with that, we have the first test tube, your first molecule that you're going to be forming. So here we're starting out with acetic acid and alcohol. Your isopentanol for your alcohol. So your organic acid, the acetic acid, the structure is shown here for you. And your alcohol is isopentanol. It's a 5-carbon alcohol with an alcohol on the first carbon. So what you're doing is kind of like dehydration synthesis back in biology. You're actually going to take the H or the OH group from one of them, the H for the other one, and then recombine the other 2. So here we've produced water. And then these are essentially sticky ends, and they will recombine. So I'll show you what we will have here. We have the 3 hydrogens off the first carbon. The second carbon will have a double bonded oxygen to it. And then that's this part of the acetic acid. It'll combine over here to the isopentanol. So we start off with an oxygen, carbon, 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 and then off of this one is another carbon. I'm going to go ahead and erase that H2O so we have more space here. So follow your honk 1, 2, 3, 4 rules. Sorry, that should be a hydrogen. Hydrogen here. Add in your hydrogens. Alright, so here we have the first 2 carbons are going to be from the acetic acid. This oxygen was the isopentanols from over here. And then we have 1, 2, 3, 4 carbons in a chain. And the 5th carbon is above the second to last carbon. And then fill in the hydrogens. So to do your hypothesis, you're going to take each of the organic acids and alcohols, take out water, and combine the molecules to form this ester right here. Your job now is to go ahead and name that ester. So don't forget how to name them. Go back to the functional groups videos if you need to. And then go online. Find out what the smell is supposed to be. And don't forget to cite that source. So that should all be in your hypothesis. Have your drawings in there in the hypothesis so that way we can see what everything's supposed to look like. For your materials, we're going to adjust this slightly from the textbook. The 50 ml beaker and the hot plate and the heat-resistant gloves, these will all be in the fume hood for you. I'll prep this for you ahead of time. You'll need 3 microscale test tubes. I will show you where they are in lab, but I'll probably try to get some kits ready for you guys. A 50 ml beaker to hold those test tubes. With that 50 ml beaker, I would go ahead and put some paper towel, like take, I don't know, about a foot worth of paper towel, combined, actually probably less than that. I would say 6 inches worth of paper towel. Cut that off, scrunch it up, and then form that in a ball on the bottom of your beaker so that that way your test tubes can sit up properly. You'll need boiling stones, so I'll have that in the fume hood for you. 3 plastic pipettes. Now the textbook in step 6 of the procedures tells you to cut the pipettes. Go ahead and do that beforehand. So this is what you're supposed to do. Cut off part of the test tube, or excuse me, the pipettes, so that it fits into the test tubes. You'll also need the organic acids, acetic acid and butyric acid. Acetic acids will be in your kits or at your tables. The butyric acid will be in the fume hood. That's the stuff that doesn't smell very good, so we're going to keep that away from the general population. And your alcohols are isopentanol, butanol, and ethanol, and those should be at your stations or in your lab kits. We'll also need sulfuric acid. This is a really concentrated sulfuric acid, so wear gloves for this one. It can be very corrosive, and this will be in the fume hood. So for lab safety, we know that we'll have butyric acid, which does smell pretty putrid, smells pretty awful. So make sure that we're wafting anything that we have to smell. And then we'll also be using hot plates, so we need to make sure we have our heat-resistant glove in on one hand. And make sure you don't have one of the rubber gloves underneath it, because the heat will transfer and the rubber gloves could potentially melt into your hand, which is not very good. And of course you will need some rubber gloves just when you're dealing with the different alcohol or the butyric acid. From your procedures from the textbook, number 1 will be done for you. That's pretty much taking your hot plate, setting it up, and starting to boil some water in there. Numbers 2 through 4, your steps 2 through 4, you're going to be labeling your test tubes. You can label your test tube using just a Sharpie, and just label it on any of the glass part of the test tube. Don't do it on the white part, because then that Sharpie mark won't come off. You're going to be smelling those different acids and alcohols in step 3, so make sure that you're wafting. Step 4 is when you're adding in the alcohol, so make sure that you're wafting during that part. Now for step 3, it'll tell you to add the butyric acid in there. Don't forget, your butyric acid is in the fume hood, so that can actually be, for that one test tube, you can go ahead and add in the alcohol first, which is ethanol, and then add your butyric acid when you get to the fume hood. This is your data table from the textbook, so make sure that you follow this and just copy this down into the data section. Forgot to say this. For step 5 is in your fume hood, so with that you'll need to bring up your test tubes. You can add your butyric acid at that time. You're adding in sulfuric acid as well, so make sure you know that you just need those 3 test tubes and everything else should be in there already. Step 6, you should already have done that. That's cutting your pipette, so bring that with you when you come to the fume hood as well. And 7 is also in the fume hood. That's when you're boiling it. So get ready with your lab partners. Make sure you know what you're supposed to do, what steps you're supposed to follow as well. Number 8, just do as directed. And number 9 is the cleanup, and we'll go to that at the end of this video. This is your data table. Go ahead and just copy that in after you've copied down your procedures. And for cleanup, for the pipettes, you can go ahead and throw them away. And for your test tubes, make sure that you wash them. We'll have Q-tips available for you since the test tube brushes won't fit in there. So use the Alkanox solution, clean out your test tubes, and if you've labeled your test tube with a Sharpie, use one of the alcohols. Ethanol would actually be really great. Just put a little bit of ethanol on a piece of paper towel and use that to rub off the label with your Sharpie mark. Alright guys, so hopefully your lab notebooks will be prepped. Come see me, email me if you have any questions. And don't forget, if your lab notebook isn't prepped, we can't do the lab. And then we probably won't be able to do the lab or do a makeup. So make sure your lab notebooks are prepped, be safe in lab, and make sure you know what your procedures are before you actually come into the lab. Have a great day. Take care.